Really, the goal today is to talk about how one can use Pulumi to find unmanaged resources, identify misconfigured such resources, and then fix them and manage them going forward with Pulumi. So really, what's the agenda for today is I'll do a brief overview of the Pulumi platform to give everyone some context. We'll review the attack plan. How are we going to find these resources, identify misconfigured resources, manage them going forward? So we'll review that plan, and then I'll walk through a demo of that plan and how we can do all that. We'll follow up with any additional Q&A and wrap up. So let's get right on with it. So when we talk about Pulumi, the Pulumi Cloud product, the platform, the SaaS, really has four pillars, if you will. So Pulumi SaaS, Pulumi Cloud is a platform, and in that platform, you have access to IAC, ESC, Insights, and IDP. IAC is probably what you're perhaps most familiar with from Pulumi. It is infrastructure as code using a programming language. So you get to use Python or Go or TypeScript or C# or Java or YAML for that matter. It is sort of where Pulumi started, but it is not the Pulumi story in toto. Alongside IAC, we have ESC. We'll just touch on it briefly today. ESC is our centralized environments, secrets, and config, allowing you to manage config data that's consumed by your IAC or by your application. Additionally, ESC can be used to generate and create temporary dynamic login credentials, like for logging into, say, AWS, which we'll get a glimpse of. But really, the star today, in a lot of ways, will be Insights. Insights is the part of the solution that allows you to point Pulumi Cloud at say, an AWS account or an Azure subscription, etc., and it'll scan the resources, bring them in for visibility, allow you to find the different resources that are managed, or I should say unmanaged, alongside any managed resources by Pulumi. And from there, you can then do things like apply our policy as code. So that's CrossGuard. That's one of the supporting characters here, is Pulumi CrossGuard, which originally was written and created in the context of IAC. Originally, the idea is that you have these policies that you can write in TypeScript or Python or Riga. We have predefined sets of policies, what we call compliance-ready policies. And originally, the use of CrossGuard was when I ran a Pulumi program, when I did Pulumi update to deploy or update or manage resources. CrossGuard can be part of that and check for any non-compliance. And in the case of IAC, there's two types of policies. There's advisory policies and there are mandatory policies. In the case of IAC, if I violated a mandatory policy, the infrastructure doesn't get deployed. It stops dead in the water. And then advisory is what it sounds like. It's a warning. The neat thing is, with Insights, I can actually run these policies against existing resources that are unmanaged by Pulumi. So it doesn't have that same sort of preemptive, preventative model, but I can still identify resources that are violating my policies, and whether they're company standards that I've captured in a Pulumi policy or our compliance-ready predefined policies. So that's where we're going to spend a good part of our time. IDP is our internal developer portal or platform. We won't really be going into that at all today, but just understand it is part of the Pulumi Cloud platform. I already mentioned CrossGuard as one of those supporting characters. Copilot's also going to make an appearance. Copilot is our AI assistant. You can use it to help you understand why perhaps a Pulumi program failed. You can use it to write code, and you'll see I'll use it to help me with my later steps around managing these resources. And then workflow is also, you'll hear us talk about it as deployments. It is essentially allowing Pulumi Cloud to run the code for you. That is not by default the case. By default, Pulumi is running wherever you're running Pulumi up, whether that's on your command line, whether that's in a pipeline, but you can also have Pulumi Cloud run the code for you. And when you do that, you can then set up schedules that we'll also leverage as part of today's demo. So what's our plan of attack? So we're going to use Insights to scan an account and find unmanaged resources. We will use CrossGuard to identify non-compliant unmanaged resources. We will then use visual import, which is the ability in Pulumi Cloud to select resources and generate an import program, basically to import them into a Pulumi stack. And now, once they're under management, we can now use IAC to fix that non-compliance, and then we'll leverage workflow to detect and correct drift going forward. And that's pretty much it. So let's go do it. So the first part is bringing that the account to scan the account. So currently I have a few accounts. I've already actually stood up, connected the account that we'll be using, but I'll walk you through the process. But essentially, you can say, hey, Pulumi, I want you to scan an account. So currently we support AWS, Kubernetes, Azure, and Oracle. You'll see Google showing up very soon, and then other service providers as time goes on. But really, it's a very simple process. You'll give it a name within Pulumi. I usually like to use a naming convention where I'll start with the cloud type. I'll use then the account's name that is sort of defined, at least colloquially, if not actually in AWS. So maybe you have something like Dev Sandbox. And then I usually like to add the actual account number, just as a way of reconfirming that when I'm looking at a given account's information, I know which one I'm looking at. And then you need to give it some credentials. And this is where we'll leverage ESC. So you can have different credentials set up. I'll show you what that looks like in a second. But, let's say for my workshop account, and if we go look at what that looks like, it's basically a dynamic login, an OIDC trust relationship that I've set up between Pulumi and that, in this case, AWS account. We also support Azure and GCP, and I'm blanking on another. But the point is, I can set up these OIDC relationships, and then that can then create dynamic, short-lived credentials. So I don't need to store long-lived credentials in any of this. So coming back, right? So I'm creating that account, AWS, blah, blah, blah. I specify my, the environment, the OIDC environment I want to use. And then I can specify which regions, in this case, in the case of AWS, which regions I want to scan. It could be all regions, could be specific regions, maybe all regions in North America, whatever the case might be. And then finally, I can have Pulumi run the scan every 24 hours. So automatically run it right now, and then every 24 hours, look for changes. And that's it. I do those couple steps and off to the races, I'm off to the races. And when that happens, I then have basically the account. So we're going to be focusing on this workshops account. We'll spend a little time in here because it has some more stuff in it. But basically, it scans, it finds the resources, and now I can start to peruse those resources. And I do that over in the resources view. So right now I'm seeing all the resources known by my Pulumi org. This includes not only resources that were scanned through Insights, the account connection, account scanning, but also it can be, we'll see this in a minute, other managed resources. So this view is everything known by Pulumi in this org. Now, what I like to do when I'm in this view is you just understand, you can take these different headers and drag them up to the top, and that'll then create groupings. So my standard view is I drag project up here, and now you can see that I'm grouped by projects, and the project might be those accounts. So there's that workshops account, there's that CE, there's that Azure one, but also these are Pulumi projects, right? These are projects and stacks that are being managed by Pulumi. So I'm seeing everything. We're going to obviously focus our attention on these scanned environments, but just understand that this view is going to show me everything that this account knows about. This org knows about. The other heading I like to pull up here, especially when I'm looking at the insights, when I'm looking at these unmanaged resources scans, is the managed by column. And what that does, and it allows me to see, as far as Pulumi understands, is what's managed by Pulumi and what's not in this AWS account, for example. So there's 6,879 resources in this thing. 45 of them are managed by Pulumi. So this is, specifically, I find them in stacks and projects managed in this org. And then there's another 6,834 resources which are not managed by Pulumi. And so coming to our workshops one, we see there's nothing managed by Pulumi in this account. Everything is unmanaged. Let me resize this again just to kind of see a little bit more. So I have, like this listener I can go drill into. I can see what's going on with this load balancer listener, the URL, the ARN. I have that, the various configuration for it. It also has these referrals. So there's links to other resources. So this load balancer is related to that. What was it? A listener I was just looking at. And so I'm able to see the load balancer, config and the settings. And again, this is all unmanaged. This is just sitting out there, in this case, out there in AWS. But I now have visibility that I didn't have before. Right before, I'd have to go scrolling through AWS pages, maybe Azure pages. I can bring it all into one view and start to see what's going on. And I can, use a little AI assistant here to find things. So I could say, find ECR and KMS keys. And when it does, by the way, it'll also give you the actual syntax that you can use in the straight, non-AI assisted link there. And it's found them. So I can, again, drill into here, and I see I have, give that a little resize again, just to make it easier to see. So I have this ECR repository. If I drill into that, I can see that it has, various settings, including a key. This OC1 key, which I think it also popped up here. Yeah, there's that key, right? So the point is I can now start to, if I want to narrow in things. And so the use case today I kind of made up for the workshop is I want to, kind of think I'm worried about my ECRs and my KMS keys. And so I can start to drill into and find these different resources very easily. But the real question is, are any of these non-compliant, right? That's the next step I care about. So great, I have these resources, they're out there. For various reasons, I probably want to bring them into Pulumi management, but the focus today is, are any of these non-compliant? Are any of these misconfigured from how we like to do things? And that's where my policy violations view comes into play. So much like we saw with the resource view, I can pull project here and start to get a little bit better viewing. If we come in here and see the different policies that are firing, we have a bunch of policies firing, a bunch of mandatory policies. There's an advisory policy, more mandatory policies. So now realize that these are unmanaged resources. And so the policies are alerting me that there's a problem. They can't do anything at this point because they're not really in the path of IAC yet. But later on, we're going to bring these policies in the path. And so we can then make sure that these resources are managed correctly and configured correctly. But we see the different policies. Again, these are basically all out of our predefined compliance-ready policies that we make available. And if I want to look for my, actually, let's do type here. Let's look for my ECR repositories and my KMS resources. And we see that we have some violations. In fact, we have, 2 mandatory violations and 1 advisory. So one is around my KMS key, doesn't have key rotation enabled. Well, that's a mandatory policy we set up. So we want to fix that. Similarly, we have a mandatory policy we're violating around the ECR repositories not having scan on push enabled. And then there's this advisory policy around immutable images. So we allow developers to, turn off immutability so that it can do sort of a faster, they don't have to keep versioning and things like that. But I have a couple resources here that are violating some important policies, and I'm going to start and I want to work on them. So let's do that. So here we're going to now start to bring these things under Pulumi management. And we'll do that through our visual import. Now, if you're familiar with Pulumi, there's Pulumi import has been around for years. I've been with Pulumi for about 4.5 years, and it's been around since then at least. And you can do it on the command line. You can do it in a couple different ways. The capability here is now I can leverage Pulumi Cloud to help me with this import. I can basically say, hey, I want to start importing some resources and managing them as Pulumi managed resources. So once again, I'm going to use our little AI assist and say, find my ECR and KMS keys, because that's where we're going to focus today. And let me pull this up just to make it a little easier to find them. There we go. And in this case, I'm going to import that ECR repo and then that KMS key that was firing the policies, was triggering the policies. I can select more things. In fact, if this next page, I don't think we'll see any, but if I selected like a VPC or something like that, it would also show me like the subnets associated with that VPC that I can import. But for now, we're going to focus on this sort of tight set just to make it a little bit easier to follow. But basically, these are the two resources I want to import. I will then say next. And really what's happening now is Pulumi is working on generating the code for these resources. And here we go. Now, this is basically code that I can use to not only import these resources, but then use to theoretically manage new instantiations, additional stacks. So in Pulumi, right, we have projects and stacks. Projects are the code. Stacks are instantiations of that program. And so here's the generated code. We basically see the repository here. We see it referencing the KMS key that we actually are also importing here. But I don't like this. There's some things I'm not too happy about. One thing is I don't like the fact that it's using this hard-coded ARN. I want this to be more generic. Really, if I was writing this from scratch, right, I would have my KMS key declaration, and then I would reference the key, the ARN property of that key resource, instead of trying to assemble or create this hard-coded KMS key ARN. I'm also not a big fan of some of the naming conventions used for the resource itself here, or this one especially is icky. So I'm going to leverage some AI assistance here. I'm going to run the enhance, which will then basically freshen up the code to make it a bit more reusable, more readable, just generally nicer. And here we go. So now we have the KMS key. It has a nice little resource name. It's declared here, and then our ECR repository references the KMS key ARN. All very good. You'll notice in this case, by the way, that the way this import works is it's generating Pulumi programs that use our resource option for import. So as I mentioned, you can do Pulumi import from the command line. You can do it, but you can also do it as a resource option in code. So I will copy this code, and what I'm going to do is I'm going to drop it into essentially an empty stack. So I have this sort of primed stack, if you will, which has nothing in it. Has one resource, which is the stack itself. If we look at it in Pulumi Cloud, we'll see the same thing. It's basically an empty stack, which just has the stack resource. So what I did is I initialized an empty stack, but this could be an existing stack with other resources in it. There's nothing stopping me from importing resources into an existing stack that's managing other resources. And that's probably what would have happened here over the course of some more time, where I would import these and maybe identify some other related resources and import them all into the same stack and have this one program that manages these all these resources together. But for now, it's empty. And so for now, I need to get these resources imported. And the way I can do that is by just running Pulumi up, because again, I'm using the import what we call resource option that says, okay, run this code, but don't make new resources, just overlay, if you will, the existing resource, or underlay the existing resource for this specific stack. So Pulumi up is running. It is, like I say, really what's going to happen here is what we're going to see is it importing two resources instead of creating these two resources. And once that's happened, once I've said, yes, I want to continue with this, it will then be, these resources will be under Pulumi management, and I'll be able to manage them and, you know, manipulate them going forward. So the one create here is the provider, the AWS provider, and then the two imports for those two resources. So I'll say yes. And voila. So now we have this stack that has been updated with the imported resources, right? So before, this was basically empty. Now we see the ECR repository being managed. We even, you know, we still see that we have that false scan on push. We have to address that. We have our KMS key, which basically has key rotation enabled by default, because it's not being, if you look at the code, you'll notice the KMS key doesn't have key rotation set at all. So the default is false, it's disabled. So I need to fix that, right? Because if I try to do another Pulumi up, in fact, I'm going to hit those policies again, because these are resources under management, and I'm going to actually have a failed Pulumi up. And it failed because I violated two mandatory policies. So as I mentioned earlier, CrossGuard and policy as code was originally implemented in the context of IAC. And a mandatory policy is a no-go, you're not, you know, do not pass go, do not collect $200 type of policy. If I have a Pulumi, if I'm trying to run Pulumi up and I'm violating a mandatory policy, the up fails. It does not create the resources or update the resources, or whatever the case might be. So in this case, because I'm violating these two mandatory policies, I cannot continue. I cannot do anything further with this stack until I address this. The advisory is just a warning. It won't be a problem. So let's fix them. It's yelling at me because I don't have key rotation enabled for my KMS key. So let's enable it. Good old AI to help. But, you know, the neat thing about Pulumi, if you're not familiar, right, is that because it is a sort of programming language model, I have all the, you know, the goodness of my IDP to be able to quickly, you know, go see the different properties that are supported by the given resource. And we see it there as well. You'll get autocomplete and squiggles if you do something wrong, right? If I come in here and set this to Mitch, you know, I'm going to get squiggles because, you know, you can't set a string to a Boolean, things like that. So you get all this wonderful immediate feedback because of this sort of programming language-based model. So I've fixed that one. And then I also need to fix the scan on push problem issue, which is being set. It's not, it's, you know, by default, it's not a default setting. So it's there. So I just have to change it to true. So now if I do a Pulumi up, I should be good to go. I should get a prompt to continue. There we go. So it's allowing me to continue. I still have the advisory policy around my mutability because I do have mutable enabled here, but that's okay. We're going to allow that. but I am updating these two properties. In fact, in this view here, I can see that explicitly. I can see the enable key rotation, which is going from the default false to true, and then my explicit setting from false to true. So let's go. Great. So now I'm managing these resources. These resources no longer are violating those policies. And I'm able to do this, like I said, if I wanted to come back in here and grab some more resources and import more resources into the same stack or into a different stack, I just repeat that process. Now, one concern I might have, because I'm a paranoid person, is, okay, great. So I am managing this resource with Pulumi now. I've set the settings correctly, but what's to stop someone, perhaps if I still allow access to the AWS console, to go in and change this? Well, nothing really. However, I can protect against it. And I can protect against it by leveraging our Pulumi deployments capability. So for any stack, I can set it up I can basically set up Pulumi Cloud to be able to run the code for me by pointing to, we have a GitHub integration and GitLab integration, but I can also just do straight Git type of integration. And once I have that relationship, once I've told Pulumi where to find the code and how to run it, and which stack we're talking about here, that then enables various capabilities, one of which is schedules. And so I can set up a drift schedule. In fact, let's just kind of see what that looks like here. So I can set up a drift or time to live or raw operation. Raw operation is set, like every day at 8, I want to do a Pulumi up. Every day at 5, I want to do a Pulumi destroy, something like that. Time to live is basically saying at a certain date and time, just shut this thing down, destroy the stack. But drift is what we really care about in this use case. It's around looking for drift. Did something change outside of Pulumi management? If something changed, detect that drift, and then optionally remediate the drift. So at a minimum, I can at least run this every so often, say every hour, and detect if there is any drift. And if there was, I can then actually set up a webhook to like hit a team channel or Slack channel or whatever. But usually in this case, I really want it to do the remediation as well. So what'll happen in this case is, if it detects drift, it'll then remediate that drift. It'll fix it. It'll bring the state, the current state, which has drifted, it'll bring that current state back in line with the desired state of the code. And that's what I have set up here. I basically, every hour, I have it running to look for drift, and if it finds drift, to remediate that drift. And we can see that running. I think it's been pretty clean. Yeah, because basically there's been nothing going on. And now going forward, if I go make a change, this will run and detect that drift and then replay and fix it. But like I said, in this case, it's just been looking for drift and not finding any differences. So everything's been fine. So what did we do? We used Insights to scan the account and find these unmanaged resources. We used CrossGuard to find non-compliant unmanaged resources. And then we used our visual import to bring these unmanaged resources under Pulumi management. Used IAC to now manage and fix the non-compliance. And then workflow or deployments to continuously check and make sure that these values don't drift, or any values really in that stack drift. And if they do, we'll correct them. Questions. So I haven't been able to really watch anything going on. Any questions out there that we want to dive into deeper?
Yeah, Mitch, there's a couple of good questions. I throw them up on the screen for you. So Pool asked, new to Pulumi, can we also define custom policies along with our code?
So, I mean, so policy is Pulumi CrossGuard. Yes, you can definitely define your own policies. The phrasing I want to dig into, because you really don't, the policies the policy as code and the code are really orthogonal to each other. So for example, in this code, in this stack, I'm not defining any policies. I'm just defining my resources, which is what I want. However, I have policies defined elsewhere, if you will, that are getting executed against this stack. But the fundamental question around custom policies, absolutely. In this case, I was using off-the-shelf compliance policies, but you can also create any sort of custom policy you want. Did that answer the question?
Yes. We have a question fresh from the audience here. Can CrossGuard be leveraged with PKO? What is the primary difference between PKO and workflows? I believe that means Pulumi Kubernetes operator in this context.
Yeah, that's an excellent question. The neat thing about Pulumi policy as code is that these policies, so we can dive into this a little bit more here. So I have these various policy packs. By the way, here are those.
If you're sorry, are you attempting to share your screen?
Am I not sharing?
No, sorry. The question overlay takes precedence over all screen sharing. So sorry. There you go. Now you're sharing screen.
Okay. Sorry, I didn't realize. So the idea, the whole way policy as code works with Pulumi is that I'm able to define these policy packs. Like I said, we have these predefined policies. I can have my own custom policies. And then I have these policy groups. And regardless of where Pulumi up is run, these policies will get applied. So they got run when I ran on the command line. They'll get, the policies will be applied if Pulumi up essentially is run in a GitHub pipeline or something. They get applied even when even in the context of deployments. If we come back to this stack, all these updates, if I ran an update through deployments, policies will get applied. And PKO is no different. PKO is essentially doing a Pulumi up. And so what will happen is when PKO runs that up, or preview even if you're doing something like that, these policies will automatically get applied to that stack. Did that answer the question?
Yes, indeed. Okay, next question. Oops, sorry, I meant to maximize that. Can Pulumi Copilot be used to deploy policy and use and then ensure compliance and get remediation suggestions? So, does Copilot have the capability to identify non-compliant resources and suggest fixes?
I haven't tried. I would think I've done a couple things where I've so I don't know if my screen is still sharing.
It is now.
Okay. Like in this stack, I can, I've done things like in the context of a stack, I can ask it, write some policies for this stack. And, it'll give me a good starting point. Yeah, this was actually just kind of giving you some off-the-shelf required tags type stuff. But you can give it, and actually in the context of our IDE support, you can do things where it's a bit more context aware of your code and ask it to write policies. But essentially it's going to help you write code that you can then publish as a policy pack, add to a policy group, that sort of thing. So it's not quite, automated from start to finish, but it definitely is there to help.
Yeah, I think that's what Mohammed was asking. And it appears that is it for questions.
Okay. Boy, we might be finishing a little early then. So wrapping up, really, the key aspect here is around dealing with these unmanaged resources. And then within that, being able to leverage all the power of Pulumi, from policy as code to the visibility that Pulumi Cloud provides, even for these unmanaged resources. And then that import capability, right? Easily bringing these unmanaged resources into Pulumi management so that you can then leverage all the bigger picture, the larger scale power of the platform around IAC, policy as code, automation, etc. So next steps, if you haven't already, you can sign up for a free forever individual Pulumi account. From there, you can do some of these things, some of the basics around IAC, quite honestly, but you can start a free trial, which will give you all the features, policy as code, insights, deployments, everything that we talked about today. And that's a 2-week free trial out of the box. And we have some upcoming workshops as well. Next week we have around building an IDP. So today we were focused more on sort of that non-IDP use case, right? Just sort of getting an understanding of what's going on out there. IDP is sort of the way to prevent that sprawl and that unmanaged resources in the first place. Being able to use Pulumi's internal developer platform capabilities to provide golden path deployments of resources that are managed from day 0, day 1, instead of having to kind of come back and find these unmanaged.